Hi everyone. In the last video, we look at ChromaDB, which is an open source embedding or vector database. It's like an alternative to Pinecone, and we do it some hands-on. We saw how to install Chroma DB, how do we index documents inside it, how do we retrieve the semantic documents, and how do we use our custom let's say the embedding model, because Chroma DB has its own embedding model. So we check with how to do with sentence transformer, and you could go and check what we have done with the Chroma DB. So what exactly in this video we're going to do? We're going to integrate, or let's say use this Chroma DB inside the Langchain library. So we know that the Langchain is, let's say, one of the popular library nowadays that we use to develop, let's say, LLM or the large language model applications. And we did cover actually Langchain in the multiple videos, so you could go, because we have a lot of videos with the Pinecone, even the Langchain as a SQL agent, document question answering using Langchain. So you can go and check those videos if you want to refresh the Langchain thing. But for the purpose of this video, I will be explaining those whatever the terms we're going to came across. So what we're going to do in this particular video, first of all, we're going to, let's say, index documents using the Langchain utilities inside the Chroma DB. Then we will retrieve those semantically similar documents for a specific query. Then we will see how do we store, or let's say persist our Chroma DB, so that you can load it and use it again somewhere else. And then we will see how do we integrate, let's say, Chroma DB with the LLM. So we will see example of OpenAI chat models like, let's say, GPT 3.5 or GPT 4. And then eventually the Langchain has the concept of chain, where you're going to combine different things. So you can combine, let's say, your Chroma DB prompt, LLM together and perform some action. So we're going to see the question answering chain, which can answer from the list of documents as a context. And then we will see there is another chain called Retriever QA chain, and we will see that thing. So first, let's start with let's install. First of all, we need a OpenAI, because we're going to use LLM from it. We require Langchain because that's what we're going to use. We require sentence transformers. So the embedding that we're going to use for the Chroma DB, we're going to use the sentence transformer, which is open source embedding. And I will also show the syntax to use the OpenAI embedding, right? And then ultimately we want to install, let's say, the Chroma DB. So let's execute this thing. We require one more thing called unstructured. So the unstructured is actually a library used by the Langchain, and that library used when you want to read files from the, let's say, directory and the process them, right? That's where we require actually this unstructured. So let's install this one also. We have set of documents that we're going to use as a part of this example. Those are the same documents. Here you could see they are all related to the pets, and we use similar or the same documents actually in the previous tutorial. So we're going to use the same document, and mostly we're going to focus on the whatever the Langchain or Chroma DB aspect of the tutorial. So in the Langchain, you could use, let's say, let me clear the output, because I have ran it earlier. Okay. So what we want to do, we have a documents, or the, let's say, list of document inside a particular directory. So from the Langchain utility, we can use, let's say, something called document loaders, and we can use the directory loader. This directory loader takes the directory path, and then using that loader, we can load the documents, and you will simply get the list of documents, right? So the document is some kind of a representation. Let's say, the Langchain is UV, and we will see how does one document, look like. So let's first of all, load those documents, and we are printing actually the length of documents, like how many documents we got. You see, it is even using internally some NLTK data. So we got the 5 documents, because we actually have the 5 documents. Another thing is that so we want to store these documents into the vector DB. So most of the time we will be chunking, because those documents will be bigger, and we want to chunk them in a small chunks, so that we can store them in, let's say, vector DB, and then we can retrieve those semantically similar chunks and then pass to LLM. So we can use Langchain has again utility for it. So the one of the popular, the recommended utility for the text splitter is called recursively split by character. So this is actually recursive text splitter. What it does here is the interesting thing. So it takes the list of separators that you can pass using which it can actually split your text. And this is what it does actually. First it try to make sure it keeps all the paragraphs intact. Like, so first it will split at a paragraph level. Then if let's say adding paragraph is actually exceeding your character limit, then it will try to split based on the sentences, and eventually it will try to split on the base of words, right? So it will try to keep those chunk, let's say your text chunk, as semantically together as possible. That's what it is actually going to do here. So that's what we have used. So we're going to use a recursive text character text splitter. It takes what is the chunk size that you want to do. Let's say we have created one function here, right, which takes some chunk size as a parameter, chunk overlap. Since we know that it might split based on a particular words also. So what if something like this happen? Few words from the sentences go into the one chunk, the other words go into the other chunk, right? So to make sure we have our context at least properly presented at least one place, we can add some kind of a chunk overlap. So if it is split, so what will happen? The two chunks will have, so let's say we split chunk somewhere here, let's say we split this chunk here somewhere. Then what will happen? This part, right, will go to the one chunk, and again some part of it actually go to the next chunk. So there will be some overlap actually. So there will be at least one chunk which has, let's say, that one sentence complete at least. So you can specify the number of characters, maybe 200 character, 100 character, something like that, right? And then we can print actually the length of documents, right? So we are simply passing the documents that we got into the earlier stage, which are those 5 documents, and we are simply splitting. So we are getting actually small docs, which you can call it as a chunk actually. Okay. Now if you say we just got 5 chunk because our documents are small, right? So if I create the let's say chunk of only 100 characters, then I will get more chunks. So I got the 27 chunks. But let's skip the bigger chunk, like 1,000 character chunk. Now we got this chunk that we can index now into the Chroma DB, right? So do that thing, we require some embedding. So what we will do, from the Langchain embedding, we're going to use, let's say, load sentence transformer embedding, okay? And then we can use a particular model called this model, all mini LM. This model we will be using. You can specify any other model, whatever you want. I have shown in the earlier video that we could even do this thing without passing model, because this Chroma DB uses some default actually model, right? It uses some default model. Now once we have, let's load this embedding, because we need to download those embedding. Okay, it started downloading. It is a small, I think less than 100 MB or something. Yeah, so it downloaded this particular model, sentence transformer model. So let's clear the output. Another thing is that just like we imported embedding, so Langchain has a vector stores. It supports many vector stores, like Chroma is one of them. The Pinecone is them. There is other vector store also. Let's say we're going to import the Chroma from the vector stores of the Langchain, and then we can create the chroma vector dp from the document. So it has a method that chroma from the documents, and the list of chunks or the docs what we created, we can pass them. And we can also give the embedding that it should use this particular embedding to actually convert these chunks into the vector, and it will get stored inside this particular db. Okay, that's it. So this is how you, let's say, load documents using LangChain and eventually index those into the DB. Now, once you have this DB, maybe we should, let's see, we get any here. So you don't see any folder or anything coming from this DB, right? Because this DB get created in the memory, because we haven't specified any persistent directory that where we should store this particular DB. So it got stored in the memory, let's say RAM or your memory. Now, what we want to do, we want to actually query this particular vector db so that we can retrieve the relevant documents, right? So let's say we said, what are the different kinds of pets people commonly own, because we know we do have one of the document which actually talks about that good thing, right? So we specify our query, we take the db, and it has a method called similarity search. So the vector db dot similarity search, we pass our query, and we should get the matching documents. And you can see how does each document look like. Each document, if you print a document, right, let's see how the document look. And you could see this is the document object. That's what I was talking about, that it create this representation the document when you create the chunk. So this document object, as you could see, it has a page content which is nothing but the text of that chunk, but it also has some metadata which mentions from which file this or which file this particular chunk belong, because this is really important if you want to go and verify, right, the answer. So this is how you get the matching docs, and you could print the it's a page content. That's what we did, right? We print the page content. Now with this chunk we can also pass some other parameter, like we want, let's say there is other function which also return the score, the matching score for this particular document, and then we can also specify how many such a chunk or the docs we want to retrieve from the vector db, and then we can print those matching doc. You could see we got actually two documents. This is one document, this is another document. Each of them has a page content metadata, but then we will also have some extra thing which is called the score. So this actually represent the matching score between this thing, right? Now this is how you can search the semantically similar document, and that's what we have seen as a without actually using langchain in the previous thing. This what we saw with the langchain, right? Now how do we store this ChromaDB? So what we can do actually, so when we create the ChromaDB or the ChromaDB from the documents, right, we can also specify one more parameter called the persist directory. And we can specify, let's say we want to store it here called ChromaDB. And then we can create that vector DB. Now, if you call the persist method, it will actually see we got this ChromaDB here, we got this index, and there are some other files, right? What we got. So this is how you can save and you can load it. So let's say we have saved it somewhere, then you can use again the Chroma. Again, this Chroma is coming from the vector store that we imported. Okay, here. So we can take this chroma, and if you give the directory path here, it will load your existing DB from that directory, right? So let's call it as a new DB, and you can load that new DB. And then now you could use this new DB to find, let's say, your document, and you see you are able to get the document by default. Okay, we are printing only one document here. So this is how it works. You, while creating the chroma db, you can specify the persistent directory, right? And when you want to use that db next time somewhere, let's say you did your experiment here in the collab, right? But now you want to use it on your server, it could be aws ec2. There you want to load it something like this in your program, or let's say on your local host, right? So you will specify the chroma, and then you will specify the embedding function that has been used, right, because it is an existing db, and then where it exactly stored so that it can load those things. Okay, now next part is actually, okay, this is all about only getting the similar docs, okay, semantic search, but there is no question answering. I'm not getting any answer to my query, I'm only getting the relevant document, right? That's the next part is called how do we integrate with the llm, right? So we're going to, let's say, as we saw earlier, that we're going to use OpenAI for that purpose, right? So Langchain has a chat model. So chat models are nothing but which support the conversation. So like we have GPT 3.5, we have GPT 4, and even there are other let's say the LLM providers that can have it, right? So what we do, first of all, we want to store our OpenAI key into some environment variable that's this Langchain is going to look for. Next thing, we import our chat model here. Then we can create the instance of this chat OpenAI model. And one of the parameter we can pass is the model name. As I told you, we can even pass GPT-4. So let's say we're going to use GPT 3.5. And this is how we got the LLM instance. Now let's use this LLM instance to get our query answered directly using. So let's think of like a document keyword, document question answering, right? So we can read more about here the Langchain question answering here. There are a good documentation is available. What we're going to use, we're going to use something called question answering chain. So from Langchain chain. So what is chain inside the Langchain? So chain is nothing but we can combine different components. Like let's say LLM is one component, there is the prompt is the another component, right? So you can combine those different components to achieve something, right? That's what nothing but the chaining those operations. So we're going to use one particular chain called question answering chain, and we're going to, let's say, load this QA chain here, and which requires the LLM, which is it is going to use LLM to actually get the answer from this document. And this is something called the chain type. So let me tell you exactly what exactly this chain type mean. So actually, when we're going to pass those documents to the LLM, right? How do we want to generate the answer? So let's look what exactly this stuff. So here is the link. You can go and you can see what is stuff means. Okay, stuff means simply stuffing or to fill something, right? So this is my query, and this is the list of documents that I retrieved from the, let's say, vector DB. So the stuff is nothing but I simply put all of this document inside this context and then I pass. This is the simple thing that we always use. So whenever we use question answering, this is what we do. We just stuff our, documents inside the context so that LLM can answer, right? But there is some other better approaches also actually, right? So what are the other better approaches? So we can, okay, maybe I should have opened in a new tab. Okay, let's say the refine, how refine works. Again, we have our query, we have a list of documents for the chunks, but if you see, it is ith document, right? So see what's happening. It take the first document, then it take the query, okay, and then it generate the answer using the model. Then it take that answer, then it again take the second document. So you actually got answer using the first chunk or the first doc. Now you're going to pass the second doc, and then you're going to pass all the information, the query you have, the intermediate answer, nothing but the previous answer you got using the previous documents, and the current document as a context. So see what's happening. This is called refining. You are generating answer using every chunk sequentially and refining your answer. Now theoretically this is definitely going to generate the better answer, but if you see what's happening here, we are making multiple calls to LLM in the sequential. So the first thing, cost, right? If you have five chunks, we're going to call five times your model. The another thing is that it is happening in the sequential nature, right? So it is going to take more time to get you the response. So if you have a chatbot or the conversational interface, it might not be feasible to make a multiple call and keep your customer or user waiting for the answer, right? But it is definitely, you can see whether you could use this refined thing, which is definitely going to give a better quality answer. But what we are using here, we are using the stuff is nothing but, we're going to simply pass our all those two three documents whatever we have directly inside the prompt, right? That's how we're going to create the chain. So let's load the chain. Now we can answer using this chain. So what does chain require? Chain require you tell me what are your the documents you have got, the matching documents and the query that you want to answer. So we can use our again the same function, which is your vector db dot similarity search, and give the query so we get the matching docs, and that we can pass. We don't need this extra comma here. And let's see what we get. Now we should get the direct answer from it. So see, we got the answer, right? This is particular the answer. But now what's happening under the hood? If you want to see what's happening under the hood, what prompt it is using, when you create the chain, you can do one thing. You can put this one particular flag called verbose as a true, so that you could see what's happening under the hood. So let's run now using this thing, and you should see what's happening under the hood. So you could see the new chain got started. You could see the prompt use actually. So this is the prompt. Use the following piece of context and answer the user question. If you don't know the answer, just say that you don't know the answer. So this is actually instruction we are passing, right? And then our document is going here. This is our document as a going as a context, and then this is the human, our queries. So that's why we are using chat model. So chat model has this syntax, right? We have some system mode or system role, which where we can put some instruction, and then human, which is your user mode, which will ask something, and then you will get the answer, right? So this is what's happening under the hood when you use it as a verbose is equal to true. Now you could even customize this prompt. So I'm not going to cover in this tutorial, but you can search, that how do we customize this particular prompt so that you can put your own prompt here, right? Now let's go and see what is the retrieval QA. Again, here if you could see, this chain requires the matching documents and then query, right? Then retrieval QA is another chain. What it does, it actually does this, finding the matching documents as a part of chain itself. So let's see what we need to create the retrieval QA. We again from Langchain chains we retrieve the retrieval QA. I think I have given the link that you can go and check maybe. Do I give the retrieval QA specifically? But you could search actually, retrieval QA of the Langchain, and we should be able to get the retrieval QA Langchain. Yeah, there is a special, it's a page dedicated, you can read more about it actually, right? Let's go back. And yeah, so we create the object of retrieval QA. There is a function called from chain time. Again we pass the LLM. You can pass whatever the stuff, refine what you want. But here we have one more argument called retriever. We want to pass a retriever. Retriever is nothing but the component or the object which will go or which will retrieve the semantically similar documents from your, let's say, vector db. So we're going to pass retriever, and then we can actually create retriever out of our vector db. So you can take your vector db as a retriever and you will get the retriever object that can be used, right? And then you can directly ask the query every time. You don't need to pass now those matching documents yourself. So this is another, let's say, interface that what you have, where retrieval qa kind of take retriever as one of the input, right? So you can play around it. Actually, there are a lot of different chain, there is a lot of different syntax that even I'm not able to remember. I just see the documents, or you can simply refer this tutorial and then modify it and play around it, right? So this is how we just saw how to load the documents, how to create the chunk. Make sure you explore the different text splitter available in the Langchain, because as per your requirement you might want to use some different splitter, right? Then yeah, this is one more thing. So instead of the sentence transformer embedding, what if you want to use OpenAI embedding, right? So the syntax is pretty, you could do something like this. From Langchain embedding, instead of sentence transformer, you can import the OpenAI embedding, and then you pass it by the name of the model that you want to use for the embedding, and it will work fine, right? But since we are dealing with, let's say, vector db, open source vector db, I thought of using the open source embedding, right? And personally I didn't find any much difference in using OpenAI embedding and the vector. I always use, let's say, sentence transformer embedding, right? And then we saw how to create the chroma db from the documents, which is nothing but the chunk. We saw how to get those similar document, even the documents with the score. How do we persist it? Then how do we initiate the LLM, use the question answering chain, and eventually use the retrieval qa, right? This is what we so. Let me know if you have any doubts, inside the comment section. Maybe I'm thinking to create a dedicated tutorial on this thing: stuff, refine, map, reduce. There are different types, that you can pass those documents to the LLM. I hope you found this video useful. Thank you.